Hey Math 8, it's the last video for this unit, interpreting graphs of functions. So at first, because of all of these different things you have to answer, it looks confusing. And I will say this, it's a really good one to make sure you check all of your answers with me. But none of it is actually very confusing. Okay, so first question right here. As x increases, so as x keeps getting bigger and bigger and bigger, notice that the y values here also keep getting bigger and bigger. So as x increases, y is getting bigger, or it increases. Okay, the rate of change. The rate of change for y as a function of x is, and you're going to notice that it's never the same. So it's not constant. So what we do here, as x, I'm going back to this one, as x increases, y increases. The rate of change for y as a function of x is not constant because this line bends. And if there's a bend in the line, that means it's not the same. If it were a very straight line, then yes, it would be constant, but it's not constant. Therefore, because it's not constant, that means there's a bend in the line. It's not linear, it's not straight. So we would say not constant and not linear for this one. For all the values of x, so if you notice on here, this blue line starts just above 0 and always stays above 0. So it's anything that's greater than or equal to 0. The y-intercept of this graph, let's see, where does it intercept this y-axis? It intercepts right here at +1, so we say it's right there. And when x equals 6, so let's see, if x equals 1, 2, 3, 4, 5, 6, if I follow this straight up or down to the line, I have to go up to right here. It crosses, that's where the blue line crosses x equals 6 right here. Again, x equals 6 here, go straight up, run into line, and then straight across. It is at when y equals 7. So when x equals 6, y equals 7. Let's do one more. All right, here's another kind of fun one. The weight is attached to a spring and moves up and down as a function. You can see right here is our little, as it goes up and down, okay? The graph is this a, what is that? Nonlinear, right? Because it's not a straight line. So it's nonlinear again, because it's not straight. The initial position or the initial weight of this, the initial means where does it cross this y-intercept right here, okay? You'll notice it crosses right here at +40, so we put in +40. Then, the weight reaches equilibrium when t equals, well, wait, what's equilibrium? Let's see, it has a little note right down here. We say that the weight is at equilibrium whenever the p of t, or the value of this thing, is at 0. So the first time this actually hits 0 is right here, which is at, let's see, halfway between 0 and 1 would be 0.5. So we put in 0.5 right there. Hey, that's all there is to it. Make sure you check your answers with me, and we will see you. Bye-bye.